All right, so 7.1 properties of normal distribution. And so don't forget, we talked about what our normal distribution would look like, that bell-shaped that bell-shaped curve. We'll talk about the characteristics of that shortly. Probability density function, PDF for short, an equation used to compute probabilities of continuous random variables. So if it is a PDF, it must satisfy the following two properties. The total area under the graph must equal to 1. The height of the graph must be greater than or equal to 0 for all possible values. So we talked about those characteristics before. I'm going to further apply them in this section. Of course, if I scroll up too quickly, let me know. So down here, a continuous random variable is normally distributed or has a normal probability distribution if its relative frequency histogram has the shape of a normal curve. And I'll scroll down in a second. Just want to make sure everybody got 1 and 2 up top. So as I mentioned, this is our normal distribution, our normal curve, bell-shaped curve. Here are our inflection points. Talk about what that means in a second. Notice our mean is in the middle. If you add a standard deviation, that's where your first inflection point is. Subtract the standard deviation, that's where another inflection point would be. So inflection points on the curve is where the curvature of the graph changes. So we talk about the curvature, talking about where it changes from being concave up to concave down. And so concave up is this U shape right here. Concave down is when you flip that. All right. We're done with inflection points. Okay, so properties of the normal density curve. And I believe we have like 8 of them. So the first one, the normal curve is symmetric about the mean. In other words, the mean is in the middle, and everything to the right of the mean happens on the left side of the mean as well. So you're talking about being symmetric about the mean. It reflects about the mean. 2, your mean is equal to the median, which is equal to the mode, and has a single peak and highest point at the mean. So remember, if you go back to your graph, it's a rough sketch, but your mean is in the middle at that highest peak. So that's what that's saying. I already mentioned number 3, it has inflection points at the mean, subtract the standard deviation, and then the mean, add a standard deviation. Area under the curve is equal to 1. So we're talking about once again, what's the red part, the red scribble is what's under the curve. And so I'll just say an example. If you know 0.7 is to the left, that means you know 0.3 is to the right, or vice versa. If you know 0.3 is to the right, then you know 0.7 is to the left. Whatever is on the right, you subtract that from 1, you'll know what's on the left and vice versa. Everything under the curve is equal to 1. All right, number 5, the area under the curve to the right of the mean equals to half or 0.5, and the same goes for the left of the curve, or left of the mean. So once again, symmetric about the mean, whatever goes on the right side goes on the left side as well. Six, as x increases, the graph approaches but never reaches the horizontal axis, which is 0. And then the same goes for x decreasing. So if you look back at the graph and how I drew it, I'm just gonna, it shows right here. I don't ever let my, the curve actually touch the bottom. That's what that represents. So as x increases, or in other words, goes to the right, it approaches the horizontal axis but never touches it. And once again, the same thing goes for when it goes to the left, when it goes decreasing. All right. Number 7 is the empirical rule. We talked about the empirical rule before. Approximately 68% of the area under the curve is within 1 standard deviation of the mean. Approximately 95% of the area under the curve is within 2 standard deviations of the mean. And then approximately 99.7% of the area under the curve is within 3 standard deviations of the mean. All right, and that's that diagram right there. Like I said, we dealt with that diagram before. And just in case you remember seeing it, a mean is in the middle. To the right of the mean is 50% of your data. To the left of it is 50% of your data. And you notice it's all broken down with the same percentages. Those percentages do not change. 34%, 13.5, 2.35, 0.15%, as you go away from the mean. So add a standard deviation 3 times will get you those 3 values. Then subtracting the standard deviation from your mean will get you the values to the left. Any questions? Any questions? All right, so this was an example. Let me erase a few things, make sure. All right, so here we have the birth weights of full-term babies are normally distributed with mean 3,400 grams and standard deviation 505 grams. I probably just did this just to reemphasize this process right here. So to give us the mean and to give us, erase this. So if they give us the mean and they give us the standard deviation, we can go ahead and use the empirical rule to figure out figure out what numbers go along with the percentages. So just want to reemphasize those percentages do not change according to the empirical rule. Those percentages are fixed. It's the numbers that go down the bottom, which will change. And those will change according to what your mean and your standard deviation are. All right, so you have your mean that's in the middle, 3,400, and then you have the values to the right. And so in the purple will be how you find the values to the right. You take your standard deviation and add it 3 times in order to get those 3 values. So 3,400 plus the 505, 3,905, then add 505 to that, which would be 4,410. Then add 505 to that, which would be 4,915. Then to find the left side, you will subtract 3 different times. 3,400 minus 505 would be 2,895. Minus 505 from that would be 2,390. Then minus 505 from that, which would be 1,885. All right, make sure we're okay. Any questions? All right, so then from there, you just put them in your empirical rule accordingly. Like I said, right side would be these values that we added, 505. Left side would be these values that we subtracted, 505. All right, any questions on the empirical rule? Make sure we're okay. All right, and let's go here. Erase some of this. All right, so here, another problem. Shade the region that represents the proportion of full-term babies who weigh more than 444 or 4,410 grams. All right. So if we lean it on the problem we had before, going back, notice it says that our mean is 3,400. Yeah. So the mean is 3,400. So if you're talking about um, leaning on what we dealt with before, this value is not going to be in the middle. It's going to be to the right. That's what I meant by this right here. Oh, less than or greater than the mean. Is it less than or greater than the mean? Of course, it's greater than. So if the mean should be in the middle, then that 4410 should be to the right of that mean. Remember, our mean was 3,400. So our 3,400 would be in the middle, and this should be to the right of that. So it says shade the region that represents the proportion of full-term babies who weigh more than 4410. So if you're talking about more than, that's always going to be to the right of your data value. Remember, if you just look at the regular number line or just look at the number 2, everything to the right of 2 will be greater than it. Everything to the left of 2 will be less than it. So, where my thing? Yeah, there we go. Since we're talking about more than, we're going to shade to the right of that value. All right. And then if we needed to shade less than, we would shade it to the left of. So just getting you used to the language. When they say more than, talking about to the right of your data value. Less than will be to the left of your data value. All right. Questions. All right. That's 7-1. Okay. All right. So that's it for 7-1. Chapter 7, if I'm not mistaken. Might as well look right now since I'm talking about it. Give me 1 second. Just want to be sure. I believe I'm correct though. Yeah, chapter 7 is only 2 sections, so we don't have to rush it. So that's all we'll do for today. Um, if anybody didn't get their work done, or missing any assignments, make sure you communicate so we can try to create a plan and get you caught up. Outside of that, did anybody have any questions, concerns, comments before we close out today? Everybody good? Everybody straight? All right, so we'll start right here. We'll do 7-2 next class, which would be, like I said, that would be it for chapter 7. So give you guys a chance to get in there before we move on to something else. So with that being said, you guys have a great day. Be safe, and I will see you on next class.